For the first exercise, when should the system testing phase begin? Do you remember these 4 types of testing? It relates to different points introduced during the class. Okay, perhaps it's better that I give you some questions to lead these exercise. For example, at first we have 3 stages of testing. Do you remember which 3 stages of testing? We have the 3 stages of testing we have introduced in the 8th chapter, if my memory is good. And user testing. Okay, thank you very much, Saji. We have these 3 stages of testing. For the development testing, the system is tested during the development to discover bugs and defects. System designers and programmers are likely to be involved in this testing process. And for the release testing, a separate testing team tests a complete version of the system before it is released to users. And the aim of release testing is to check that the system meets the requirements of system stakeholders. And for the user testing, users or potential users of a system test the system in their own environment. So you see these 3 stages are quite different. And the relationships between this exercise and these 3 stages of testing is that here what is said, unit testing and the 2 others, they compose 3 levels of granularity of the development testing. Do you remember? The 3 levels of granularity during development testing. For the 3 levels of granularity during development, we have the unit testing, where individual program units or object classes are tested. And unit testing should focus on testing the functionality of objects or methods. Component testing, several individual units are integrated to create composite components. And component testing should focus on testing component interfaces. System testing, where some or all of the components in a system are integrated and the system is tested as a whole. So system testing should focus on testing component interactions. Here, we have these 3 levels of granularity during development. And we say that, you see, unit testing is before the system testing. And system testing, we may call it, okay. And what about beta testing and functional testing, white box testing? They are about different, they are very dispersed. So we need to find some ways to call them together. For the functional testing, it's about the release testing. The functional testing, we may also call it release testing. It is the process of testing particular release of a system that is intended for use outside the development team. So you see here, we say release testing is usually a black box testing process. The tester is only concerned with the functionality and not the implementation of the software. So we may call this functional testing as release testing too. System testing is behind this functional testing, behind the unit testing. And for beta testing, what is it? Beta testing? Do you remember the definition of beta testing? What have you said here? A release of, I'm sorry, early access to the software. A release of the software is made available to our users to allow them to experiment and to raise problems that they discover with the system developers. A release of the software made same thing. Okay. And what's the relationship between beta testing and, for example, unit testing or functional testing?
Jiangxi,
Yeah, Kaya?
please repeat your question.
Yeah, I say what's the relationship between beta testing and unit testing or functional testing? Beta testing falls underneath unit testing. Underneath. Can we call it like this? You see, beta testing, it is one type of user testing, yeah? Do you remember the three different types? You remember the three different types of user testing? Okay, oh, okay. Okay. Thank you. Thank you, Kaya. And do you remember those three different types of user testing? Alpha, beta, and acceptance. Very good. Thank you. Thank you very much, Kaya. Yeah. So you see, beta testing, it is a type of user testing. And user testing, it is the last stage of testing. System testing is one level of granularity of development testing. So system testing normally is before beta testing. As we have said, system testing is after unit testing and after functional testing. So with this method, we can know that system testing is after white box testing. And white box testing, it's the test to see if each conditional loops or structure, each possibility works. For the white box testing, it is structural, yes, the structural loop. So normally it's after white box testing, we will begin system testing. For B, which factors must be most considered when developing acceptance criteria? Yeah, this one is yeah. Which one do you think it is the correct answer? Which one will you choose here for the B? For the I'm sorry, for the second one. Okay, perhaps I'll leave you some time to do from exercise 2. Okay, thank you, Kaya. From exercise 2 to 5. Okay, for the exercise 2 to 5. Kaya, you have said B. And anything else? B for just number 2. Okay. And number 3, number 4, number 5. So we have B for number 2 as said by Kaya, and B for number 3 as said by Sadama. Any other propositions? 3, 4, 5. 3, D, D, C. Okay. We'll see these exercises together. For the second one, which factors must be most considered when developing acceptance criteria? When we talk about acceptance criteria, we think about the stakeholders, the end users. Or for them, they need us to develop a system that corresponds to their requirements. So for the second one, surely we need to consider all these factors like user availability, match with requirements, ability to benchmark systems, schedule of system delivery. Yeah, we must consider them, all of them, but the most considered when developing acceptance criteria is the requirements. So here is B. And for third one, software work is work done to enhance software functionality, correct errors, and improve the performance of software. Here, this question relates to our last chapter, which is the software evolution. And software evolution, we have talked about software maintenance. So this is the objective of the software maintenance. We choose B2. And for the fourth one, what is configuration management in software engineering? For this exercise, it's not too difficult neither, as we can analyze all these 4 options. The first one, overall management of the design of the system. The second one, management of the configurable components in our system. Third one, the identification of the configuration of our system at discrete points in time to control changes to the configuration. Fifth one, in object-oriented programming, the management of objects that control the configuration of some other functions in the system. So here, for this fourth one, at the first sight, we may think all of them are correct, but when we analyze them in detail, we can see that C is the most complete, the identification of the configuration of a system at discrete points in time to control changes to the configuration. We have said for the configuration management, it is also very important for the for the software evolution. And the software evolution, it concerns always with changes. So here we have C as the correct answer. And for D, software engineering is best described as the practice of designing, building, and maintaining off-the-shelf software from prefabricated parts. The practice of designing, building, and maintaining ad hoc software without the use of formal methods the practice of designing, building, and maintaining reliable and cost-effective software using standard techniques. The practice of designing, building, and maintaining fast and flexible software specifically for engineering applications. Among these 4 exercises, we should also analyze them as the fourth question. Yeah, the fourth one. You see, software engineering, we have also in most cases we need to design or build. We need to build the system by ourselves, not off-the-shelf software. And for the B, the practice of designing, building, and maintaining ad hoc software without the use of formal methods. We don't say without the use of formal methods. Sometimes we need formal methods too. And for C, the practice of software. The practice of designing, building, and maintaining reliable and cost-effective software using standard techniques. Yeah, for the moment, it seems right. And for D, the practice of designing, building, and maintaining fast and flexible software specifically for engineering applications. Not just engineering applications. We may have also other business and applications, etc. So here for the fifth question, we choose C. Okay, so thank you, Said. No, I'm sorry. Thank you, Kaya. But it's not DDC. For the second one is B. For the third one is like Saddam. For the fourth one is C, and for the fifth one is C2. Okay, I will write it here. 1 to 5. It is C, B, B, C, C. And then we have the 6th one to the 10th one. Five minutes for these 5 exercises. Fossil has answered for the 6th one, E, and 7, 8, 9, 10, 7, D, 8, 8, 9, 10. Okay, we'll begin by these 2 exercises. For the 6th one, we ask for the software crisis. Yeah, software crisis. It includes all these 4 answers, 4 questions. How expensive software is to develop? How long it takes to build software? How hard software is to write? How quickly software becomes obsolete? And for 7, the software crisis exists because, first of all, you are right. They are I'm sorry. There are proven scientific methods for building robust, efficient, reliable, and cost-effective software, but they are too difficult for most software developers to understand. Sorry, Kaya, you thought it was C. There can never be a proven scientific method for building robust, efficient, reliable, and cost-effective software. I'm sorry, Kaya. This one is rather D, not C. In fact, there are some methods for building a good software, but it's difficult to understand. That's why we have the crisis. So yeah, as Faso, you are right. It's D. And for the eighth one, the 8, 9, 10 will continue after the break. Now we'll have a break of 10 minutes and I will note for your attendance. Bike. We have 2 absences today, Ken and Kamruzama. Yeah, Ken and Kamruzama, they're not here. And first one has answered for the 8th, 9th, and 10th. The 8th one, we ask, what is the single largest computer-related cost for most organizations? This one, do you have any other propositions? You see here, we have answers like D, B. Yeah. It's software analysis and design, software implementation, software testing, and software maintenance. In the last seminar, last week, we have talked about software evolution. There, we have said that software maintenance cost is the, in many projects, software maintenance takes up the majority of cost for most organizations. And for the 9, a requirement specification. What is a requirement specification? Here, we have several propositions, choices. A rough list of things that the proposed software ought to do. A precise list of things that the proposed software ought to do. A formal list of things that the proposed software must do. An estimate of resources, time, money, personnel, etc., which will be required to construct the proposed software. Here, whether the requirements specification should be rough or precise. Here is not what exactly precise like this. It depends on the customers and developers. But what is essential is we must know what the system must do. So it's a formal list of things that the proposed software must do. So here for the 9th one, we should choose C. It's not B. And for the 10th one, the testing phase of software development doesn't require. You see, it doesn't. Testing that the implementation compares correctly, testing that the implementation matches the design, testing that the implementation matches the requirements, testing that the components of the implementation work separately and together, testing that the implementation interacts correctly with the environment. Here, for A, surely we need to guarantee that the implementation compares correctly, else we cannot use the system. The implementation matches the design, yeah. The implementation matches the requirements. It's the same thing. Yeah, it corresponds to the second exercise. It is the matching with requirements is the most considered factors when developing acceptance criteria. So, sure, we need to test that the implementation matches the requirements. For C, testing the components of the implementation work separately and together. Here, we need to make the difference between components and unit. Here, components of the implementation work, it is not exactly unit. So we can test them together, but we don't need to test them separately. The fifth one, testing that the implementation interacts correctly with the environment. Here, when we have the user testing, we will execute the system in the user's environment. So surely we need to test the implementation interacts correctly with the environment. So this one, the right answer is D. CDCCA. 11 CDCCA. Okay. And we wait still 2 minutes for others if there are any other propositions. 2 minutes. For Ramnak, you say the 11th should be D. Okay. Yeah. So now we'll check for these 5 questions. This one, for the 11th question, we have talked about it in the 8th chapter, I think. Yeah, in the 8th, exactly. In the 8th chapter, software testing, we have said that validation, we ask the question, are we building the right product? And verification, we ask, are we building the product right? So here you see the difference between verification and validation is there are different names for what is essentially the same process. Obviously, it is wrong. B, verification tests validation. It asks testers to verify that the code is valid. You see, for validation, we say validation is yeah. When we ask these 2 questions, it's already D. It is correct. Verification relates to implementation, whereas validation is principally concerned with design. It's not for verification. We need to verification. We need to ensure that our system developed corresponds to the requirements. So verification is the requirements and validation is to check if the product works well. So as said by Ramnak, the 11th is D. You can find it, I think, yeah, in the slides.
But Laoshi,
Yeah.
the slides. Oh, okay. No, now I see. Now I see in the slides. So I mixed the two up. I thought that validation was in the slides. Are we building the product right? So now I can see that it's the other way around.
Yeah. Okay.
Laoshi.
You're welcome, Kaya. Yeah, it's here. We have this slide. Yeah, the difference between verification and validation. So for the for this this question, the right answer is D. And then we have the 12th. A good test program. What is a good test program? A finds a different error each time it is run. B finds the same error by several different methods. C has a low probability of finding a known error. D, none of the above. And what do you have given? As answer is D, none of the above. We say a good test program normally should find errors with the largest probability. Yeah. Ramnak, you are right. Yeah. Yeah, that's true, Ramnak. It's if we can find a different error each time it is wrong, it's a good test program because we can find the errors by us developers instead of by other users after delivery. So it's better. But if we find the same error by several different methods, it doesn't very efficient. And normally we should a good test program should have a high probability of finding errors. So C is wrong. We need to choose A here. And for 13th, logical errors are typically found where you least expect them in the code that is least commonly executed by the compiler at compile time at random points in the code. Logical errors. Here, I forget where, at least in Java programming, we have talked about logical errors. For example, what kind of logical errors we may have when we, if we need the quantity, if we need to know the least quantity of bottles, how many bottles can support or can stand a certain number of water or other liquids. Normally we'll say bottle, the number of bottle is bottle is an integer. We should we cannot give a floating number for number of bottles. But for the capacity, the total capacity, it is, we may also say it, liters divided by units. That means how many liters can be how many liters can support by each bottle? Normally we say it is like this. Are you sure? Yeah. Do you agree with this? It's a simple example. We may say all of these are integers. Number of bottles, the total liters, and the unit. Yeah, the liters supported by each unit, the capacity of each bottle. Normally it's like this. Do you agree with this expression in the program? If we need to know the number of bottles we need to the number of bottles we need for the total liters of milk or water. Is it like this? The expression. Do you have different ideas for this one?
Now, please repeat the example you just gave.
Yeah. For example, to deal with a real problem, we may have an algorithm, and in that we have a small point. We need to know the number of bottles we need to be able to transport a certain liters of milk. Then the number of bottles is it like this to does this expression can calculate the number of bottles we need? Here is the bottle, here is liters of milk, here is the capacity of each bottle. Yeah, perhaps it's better to write capacity. Do you agree with this? Pardon?
I don't understand the example.
Yeah. This example is that we need to know the number of bottles we need to transport a certain liters of milk.
Yes.
Then, is this expression correct to calculate the number of bottles? Here you see is number of bottles, total liters of milk, for example, and the capacity of each bottle. Is this expression true? That can it help us to calculate the number of bottles needed?
No.
Why?
Because as I can see, it's not where you least expect them.
Pardon?
It can't be where you
Else you can
isn't
correct
it?
it directly. You can if you have another proposition, you can correct it. You can write your propositions.
Laoshi, I know. I don't.
Yeah.
I can't figure out another proposition now, Laoshi.
Pardon?
I can't figure out another proposition. I think.
Yeah, but for you, this expression is wrong.
Okay. Okay, no,
Yeah.
that's fine.
For you,
Yes.
but according to your opinion, this proposition, this expression, it is not correct to is it correct for you?
No, Laoshi, it's not correct.
Why? Can you explain a little your ideas here?
Well, but my idea here. So the question is logical errors are typically found, and then my answer was by the compiler at compile time. And the reason why I chose that answer is because A, he said where you least expect them, which can be true, but in this context, I don't think it is. B, in the code that is least commonly executed, it also can be true, but I don't see it being right in this context. And D, at random point in the code, okay, it's true, but it just doesn't work for this instance, for this question. So that's why I chose C instead.
Okay. Okay, thank you very much, Kaya, for sharing your ideas about this question. In fact, why I asked for this example, because this one is here is an example of logical errors. You see, it is a logical answers, and here it's a logic. Here we have a logical error here, as we say all of them are integers. For example, we have 46 liters of milk, and each bottle, the capacity of each bottle is 5 liters. Then with this expression, the number of bottles is 9, yeah? With this expression, if we code it like this, if we code the program, this algorithm, yeah, if we code it, we'll receive the answer 9. Is it right or wrong for you? Is it clear? I'm not sure if you...
Yes, Laoshi, now I understand.
Yeah.
Number of bottles is 9.
Yeah.
And we are using int variables, right, Laoshi?
Exactly. But normally here, it is a logical error because number of bottles we need is not 9, it's 10. We need 10 bottles to transport these 46 liters of milk.
Yeah.
Normally, this one, we
it's
should
10,
not...
exactly.
Yeah, we should not code it like this. We should code it like this.
46.
We should code it like this to be correct.
Oh, okay, +1, right.
No, I'm sorry. No, not +1. It depends on It depends on situations. If this one, yeah, we need we need a condition. If if total, I'm sorry. If this one and this one, if the remainder, yeah, exactly.
Then +1.
Yeah.
Then you +1. Yeah, something like that.
Exactly. Yeah, you are right.
Or even better, yeah.
You get it now. You see, with a little problem, we can make, yeah, we may have logical errors. That's why we here for this one, for 13, we choose A, where we least expect them.
Okay, now I understand.
You see, with this example, this error will not be correct, will not be recognized by the compiler. We'll parse it directly. We think it's true, it's correct. But when we analyze it, we see that there is a logical error, and this error is not very easy to find it. It's not very obvious, even it is very simple. Okay, thank you, Ramnak and Kaya. So you see here we choose A, okay? For exercise 13. And then for exercise 14, what's your answer? 14 is C, 15 is A. Yeah. It's correct for 14 and 15. For the 14, which statement about the preliminary design stage of a software development project is true? The preliminary design stage, it is it comes from the initial meetings between the customers and the programmer. As here, the preliminary design, we need to make sure that customers and developers, we agree with the specifications, the requirements. Then for 15, what refers to whether appropriate software development strategic are being employed and the product is being built properly. Okay, here, this one is the validation. We have talked about it already twice. The validation. And then for the 16, for the 16th, exercise 16, what's your idea about this one? This question? 16A? Okay, and others? Okay, we'll not wait anymore. Yeah, the 16 is A. Predictive metric is used to make prediction about the software later in the life cycle. And for 17th, okay, thank you, Kaya and Ramnak. 17th, a system that is composed of modules is called what kind of systems? Okay, thank you, Kaya. And any others have other propositions? Yeah, you are right, in fact. Yeah. Kaya and Rana, you are right. It's modular systems. And for the 18th, what is the effort required to transfer a program from one environment to another? Yeah, it's I think these questions are rather simple. Here, pay attention to from one environment to another. Transfer a program from one environment to another. What is the effort required? Interoperability? In fact, it's the portability. That's why we say we can transfer a program from one environment to another. If we say if we can use our program to solve one problem and another, that may be the reusability. But when we transfer a program from one environment to another, it's the portability. Yeah. Okay. For the other exercises, you can try it by yourself from the 19th. Yeah, we'll continue these exercises later. And don't forget your assignments. It's important for your final, your final marks also. Do you have some questions still here for this part?